Now this is the last lesson for chemical calculations. We're going to look at a specific example of how chemical calculations can be put to use in an experiment. Alright, the type of experiment that we're going to look at is called volumetric analysis. Now what is volumetric analysis? In chemistry, analysis is something it's like an experiment that we perform to find out something of interest. Alright, there are two kinds of analysis in general. You can have quantitative and qualitative. Alright, by quantitative analysis, we want to find the amount of substance. Okay, so for example, if we have a solution of acid, we want to find the amount of acid that's present in that. By qualitative, we want to find the identity of substance. Okay, so for example, if we have a solution, we want to find out what are the ions that are present in the solution. This is called qualitative analysis. Now, for quantitative analysis, to find out the amount of substance, there are different ways in which we can do so. One of them is by analyzing volumes. Okay, so what do I exactly mean by analyzing volumes? By now, I believe you should have performed a titration before. Alright, we're going to look at it in greater detail later. In titration, the main objective of the experiment is to find the volume of solution used in the burette. Alright, why is that important? Because from the volume of your solution used in the burette, we can go on to find out the amount of substance, amount of a certain substance in your conical flask. Alright, so this form of quantitative analysis by analyzing volumes of solutions form is called volumetric analysis. Right, in other words, volumetric analysis, a specific example of volumetric analysis is the titration that we have done in the lab. So just a quick recap of what titration is. In titration, we have a solution in the burette, and then we have a solution in the conical flask. So for example, you can have the alkali in the burette, and then we can have the acid in the conical flask. Alright, the solution that that is to be placed in the conical flask is usually measured using a pipette. Okay, so the volume is fixed. It is usually 25 centimeter cube. Alright, and in a titration, what we do is that we will add the alkali slowly from the burette until the acid is just nice reacted away. Now, how do we know that the acid has been just nice reacted away? We can add an indicator. Alright, remember, when the acid is just nice reacted away, in the context of O-levels, the solution will be neutral. Right, so as a result, the indicator will show a different color as when it's acidic or when it's alkaline. Alright, so when the indicator changes color, it tells you that you have added just enough alkali to react away all the acid. Okay, so in a titration, we usually measure the volume of your alkali needed. Okay, so the one that we have done in the lab, if you can recall, we have used methyl orange as the indicator. So if the acid is in your conical flask, the original color is red, and then at the end point it will become orange. If you have added way too much alkali, it will turn into yellow. Alright, before I go on, there are a few new terms that I want to teach to you. The first term is called titrant. Alright, the solution that's placed in your burette is called the titrant. Okay, then the next term that we need to learn is called endpoint. Now the point at which your indicator changes color is called the endpoint. And lastly, the volume of the acid or alkali required, so the volume of the solution used in the burette, is called the titer value or titer volume. Okay, so the objective of a titration is to find the volume of titrant required to reach the end point of a titration. Alright, and this volume of titrant used is known as your titer value or your titer volume. Now let's look at a question that involves titration. Now in this question, the sulfuric acid is being placed in the burette and your aqueous ammonia is being placed in the conical flask. Okay, how do I know that? Because the question stated 25 centimeter cube of ammonia required this volume of sulfuric acid to achieve endpoint. Okay, so this is actually your titer value. Okay, you are also given the concentration of sulfuric acid, and the thing that we need to find now is the concentration of ammonia. Alright, now for chemical calculations involving titration, we can always solve it using the 3C approach. Alright, so this is what I mean by 90% of the chemical calculations can be solved using the 3C approach. Now I'm going to show you how to solve it using the 3C approach before I show you a little shortcut. Okay, so in the 3C approach, step number 1 is to convert to moles. What are we able to convert to moles for? If you look at the question, we have the volume of sulfuric acid, we have the concentration of sulfuric acid. That will allow us to find the number of moles of sulfuric acid. Okay, which is 0.00241 moles. Alright, next we need to compare mole ratio. Now the thing about this question is that the equation for the reaction is not given. Alright, so you need to construct on your own, and this is not an easy equation to construct because it's tricky when you have ammonia where the hydroxide is not shown. Okay, so ammonia reacts with sulfuric acid, and many of you all can recall that if an acid reacts with an alkali, it will give you salt and water, right? But this is special. Why is it special? It's because for ammonia, for aqueous ammonia, the water is not shown, right? As a result, in this equation, you don't see water in the product as well. Okay, so if we look at the equation, it's still not balanced. In order to balance, we need to add some numbers in front of each substance, and the number that we need to add is a 2 in front of ammonia. Right, so that will allow us to know that 2 moles of ammonia will react with 1 mole of sulfuric acid. So the number of moles of ammonia will be equals to 2 times that of sulfuric acid, and that will be 0.0482 moles. Okay, now lastly, step number 3, convert from moles. So now we have number of moles of ammonia. We need to find the concentration of ammonia. Alright, so meaning again we are going to make use of this equation. So in order to find concentration, we need to take number of moles divided by volume. Right, so concentration of ammonia is equals to number of moles divided by the volume. Now bear in mind that volume is in centimeter cube, so we need to divide by 1000 to convert it to decimeter cube. Right, so that will give us the concentration of ammonia. Okay, so two things to take note here when performing chemical calculations involving titration. First thing is that we can use the 3C approach. And second thing is that we will most likely, again 90% of the time, be using this particular triangle because we are looking at solutions. Now, a common mistake that students will make in this particular example is that when they see ammonia, right, when they see the word ammonia, it immediately strikes them that it is a gas, alright, and they will start to put in 24 dm cube as the volume, right? So that is why when we see volume of something in a question, you need to ask yourself, is it volume of a solution or volume of a gas? Right? In titrations, we are forever dealing with solutions. So 24 dm cube should never appear in a titration question. Now, there's actually a shortcut approach that's based on the 3C approach. Right? It's essentially the same. Right? But when you see a chemical calculation question involving titration, acid-base titration, you can actually use this formula over here. Alright, so how do we obtain this formula, or how do we interpret this formula? Is that the concentration of acid times the volume of acid divided by the concentration of base times the volume of base is equals to the reacting ratio between your acid and your base. Okay, how do we get this equation? Number of moles of acid is equals to concentration of acid times concentration of volume of acid. Number of moles of base is actually concentration of base times volume of base. Alright, so when we take equation 1 divided by equation 2, you will get this general equation here. Alright, let's see how we can apply this in the earlier question. So in the earlier question, we were looking at ammonia reacting with sulfuric acid to give you ammonium sulfate. Okay, so let's write out the equation again. Now, from the balanced chemical equation, we can see that the number of moles of acid divided by number of moles of base is actually 1 over 2. Alright, so next we need to just fill in the remaining unknown values. Fill in the remaining values that are known from the question in order to find the unknown value. Okay, do we have the concentration of acid? We do. Alright, do we have the concentration? Do we have the volume of acid? We do as well, which is 21.9. Okay, divided by, do we have the concentration of your alkali? No, that's what we want to find, but we have the volume of alkali, right, which is equals to half. Now, if you were to solve this chemical equation, you will find that it has the same value as what we have found before, which is 0.193. Okay, now some students would prefer this method because there's no need to actually compute for this part. You will find that the 1000 actually cancels out. Right, so when you use this formula, finding the answer will be more straightforward. Okay, but for those of you who find it hard to use this formula, you might want to use the 3C approach. Right, both of them will lead you to the correct answer. Now, for the last part of chemical calculations, I want to introduce you to a particular type of titration. Now, this type of questions is usually not in the O-level syllabus, right, but rather in the A-level syllabus. However, in many prelim questions, in order to stretch students further, we are increasingly seeing questions like this. Alright, so it will be good for you to know what is a back titration or what is an indirect. Another name for back titration is called indirect titration. Okay, so let's take some time and read the question, and then I'm going to tell you what is actually happening. Now in this question we have a sample of chalk. Okay, chalk is primarily made up of calcium carbonate plus something else. Alright, so the 0.125 grams is actually the mass of impure calcium carbonate. Okay, so now in order to find out how much of this chalk is actually calcium carbonate, alright, we need to react the calcium carbonate with something. Alright, however, calcium carbonate is a solid, so there's no way it doesn't dissolve in water. So there's no way for us to perform a titration on calcium carbonate. Alright, so what we need to do is this. We put the calcium carbonate in a conical flask. This is a solid, and we are going to add excess of an acid to the calcium carbonate. So what is going to happen is that all your calcium carbonate will be reacted away. Correct? Because we have excess acid, all your calcium carbonate will be reacted away, and at the end of the reaction there will be some acid remaining. So now we'll perform a titration. Okay, so now we'll perform a titration to find out how much of the acid is remaining. Okay, and how do we do that? Is to find the volume of alkali that's needed. Okay, so from the volume of alkali needed to react with the acid, we know how much acid was remaining, and knowing how much acid we added in the first place, we would know how much acid had actually reacted with calcium carbonate, and that will allow us to find the amount of calcium carbonate. I know it sounds very, very complicated, but now imagine this particular real life scenario. Okay, it may sound a bit violent, but if it's what it takes for you to understand what is a back titration, so be it. Alright, imagine that a classroom contains about maybe 25 landmines. Alright, and then I know that one landmine can take out a particular person. Alright, so how do I know how many landmines are there in the classroom? I cannot go in myself, because if I go in myself and I step on a landmine, and then that's it, I'm gone. Alright, so what I'm going to do is, I know there are about 25 landmines, so I send in 40 soldiers, for example. Alright, and after all the explosion is over, alright, I'm going to go into the classroom to find out how many soldiers are still alive, are still remaining. Right, so for example, if I have 10 soldiers who are still alive, that would tell me that 30 soldiers have passed on, have stepped on the landmine, and that would also tell me that there were actually 30 landmines in the classroom. So this is the meaning of a back titration. We put in an excess of a reagent, and then after that we find out how much is remaining, and by how much is remaining we can find out how much was actually reacted. Okay, so now I'm going to use this diagram to show you how can we solve a back titration question. Okay, using the question that we saw just now. The question involves some impure calcium carbonate. We want to find how much calcium carbonate is there in the chalk. Okay, so this is the main thing that we want to find, right? So we react calcium carbonate with an excess, all right, with more than enough hydrochloric acid. All right, so through the reaction, this amount of hydrochloric acid will be reacted, and then this amount will be remaining. So how do I find out how much acid was remaining? I titrate the resulting mixture with a third reagent, with my sodium hydroxide. Okay, so this remaining acid will be reacted with sodium hydroxide. So in a back titration question, how do we solve it? Is this. that first we need to find the number of moles of sodium hydroxide. So this is step number 1. We find number of moles of sodium hydroxide, and from number of moles of sodium hydroxide we can actually know the number of moles of HCl that was actually remaining. Okay, and the question usually will tell you the total amount of hydrochloric acid that was added. So we can actually find the total the number of moles of HCl reacted by taking total minus remaining. Okay, so by taking total amount of HCl minus the number of moles of HCl remaining, we will find the number of moles of HCl that had reacted with calcium carbonate. And then from the number of moles of HCl that had reacted with calcium carbonate, we can lastly find number of moles of calcium carbonate. Okay, so the workflow for a back titration question is something like that, right? We always start from we always have to go backwards, starting from the last piece of information. All right, from the amount of sodium hydroxide, we will find the amount of acid that was remaining. From the amount of acid remaining, we can find the amount of acid that had actually reacted with calcium carbonate, and that will allow us to find number of moles of calcium carbonate. Okay, so let's put this workflow into solving the question. Now, step number 1, we need to work backwards. So we need to find number of moles of sodium hydroxide. Are we able to do so? Yes, because we are given the volume and we are given the concentration as well. Okay, next, after finding the number of moles of sodium hydroxide, that will allow us to find number of moles of HCl that was remaining. Alright, so is this amount of HCl that was remaining that was actually reacted with sodium hydroxide? So how do we find that? We need to firstly know the reacting ratio between HCl and sodium hydroxide. Alright, so we need to write out the chemical equation, which is like that. So from the chemical equation, we can see that 1 mole of hydrochloric acid will react with 1 mole of sodium hydroxide. Alright, so the number of moles of hydrochloric acid that had reacted with sodium hydroxide is the same. Okay, so that also tells us that this is the amount of hydrochloric acid that was remaining in the mixture. Okay, so next we need to find the total amount of hydrochloric acid that was added. Remember, in order to find the amount of calcium carbonate, we need to add excess of hydrochloric acid. Alright, so we need to find the total amount of hydrochloric acid. Are we able to do so? Again, yes, because we are given the volume and concentration of hydrochloric acid that was added. So we can find the total number of moles by taking volume times concentration. Okay, so we have found the total amount or total number of moles of hydrochloric acid. We have found the amount that was remaining after it had reacted with the chalk, with the calcium carbonate in chalk. So with that, we can find the number of moles of HCl that had reacted with calcium carbonate by taking the total minus the amount that was remaining. Okay, so now that we have found the number of moles of HCl that had reacted with calcium carbonate, we can therefore go on to find number of moles of calcium carbonate reacted. Okay, and once again, in order to do that, we need to compare the mole ratio. So we will need the balanced chemical equation again. So the reaction between calcium carbonate and hydrochloric acid is like that. right, you will produce a salt plus carbon dioxide and water. So this equation is not balanced. In order to balance, we need to put a 2 over here. Okay, and then the equation is balanced, and from there we can see that 1 mole of calcium carbonate will react with 2 moles of hydrochloric acid. So since the number of moles of hydrochloric acid was this, the number of moles of calcium carbonate will be that divided by 2. Okay, and then the last step, or rather the second last step, because we need to find the percentage purity or the percentage by mass of calcium carbonate in the sample. So we need to find the mass of calcium carbonate, which is number of moles times molar mass. The molar mass of calcium carbonate is 100, so we will get 0.09875 moles. Grams. Okay, and then last step is to find your percentage purity or percentage by mass. That would be the mass of pure, which is 0.09875, divided by the mass of impure, which is 0.125 times 100%. And that will give us a percentage of 79%. Okay, so as you can see in a back titration question, we need to perform chemical calculations. We need to perform 3C calculations, alright, for 2 separate reactions. The first reaction is between calcium carbonate and hydrochloric acid, alright, and then the second one is for the remaining acid with sodium hydroxide. Okay, so fundamentally a back titration is also chemical calculation. We just need to perform it twice for 2 different reactions. Alright, and it's especially important for you to have a clear understanding of what is going on. Again, we have the amount of an unknown, something that we want to find out. We add, okay, let's call it reactant A. Alright, we want to find out the amount of reactant A. We add an excess of another reactant, reactant B, so that A will be completely reacted. Okay, so at the end of the reaction there will be some B remaining. Then we react the remaining B with a third reagent, reagent C. So from the amount of C reacted, we know how much B was remaining, and from the total amount of B added, we know how much actually reacted with A, and from there we will know how much A is present. So this is the concept of a back or indirect titration.